And first off, welcome to our Imagery, Reality, and Digital Twins seminar. This is actually mine and this is first imagery event here in Taiwan. And I'd like to thank the IDT team for making this possible. And also thank all of you for coming in today and taking the time out of your day to be here. So the purpose of today is about bringing our imagery and GIS community together. And this afternoon, our team will talk about imagery and remote sensing and how it's being used in GIS. We will also share more about the latest trends, technology updates, and use cases on how digital twins are being adopted around the world. So in the early days of GIS, just getting access to imagery was actually a very big deal. Low resolution, long delays, and a lot of manual work to make this information and imagery useful. But today, with reality mapping, it allows us to capture the world at any scale, with any sensors, from satellites to aircrafts, drones. You can see at the bottom, even personal devices. We now have the capabilities to capture and extract resolutions of up to 1 centimeter. So the old distinction between platform and sensors are disappearing. What matters now is actually how quickly we can get and how accurately we can turn raw data into usable reality. And this is some of the exciting things which we can do. Create a highly accurate, photorealistic digital representation of the real world. And this is actually a drone imagery produced by our reality mapping tool, processed fully automatically with ArcGIS Reality. So in today's world, image resolution is not an issue. The challenge today is actually what we do with this data. And how can we turn this imagery into insights? And why is it important? So 2 weeks ago, as Typhoon Regasa approached many countries in the region, early warning from advanced weather prediction tools provided precise insights into its timing and also in its impact. So this level of foresight actually allowed individuals, businesses, authorities to prepare effectively. Me and Liz were actually in Hong Kong 2 weeks ago whilst the typhoon was happening. And we were told 1 week in advance exactly what time we would hit Hong Kong and what time it would beep. And it was accurate to the hour. So I think this tells us that it's a powerful reminder that timely analysis and actionable insights are not just useful, but they potentially save millions of dollars in damages, and more importantly, save lives. Therefore, they're critical. So, in order to achieve these insights, we at Esri have a vision. And that vision is to bring people, insights, and imagery together for a modern GIS. And with this modern GIS, it can lead to new ways in which we actually deliver insights and build awareness of location. So you may be asking, what actually is a modern GIS? Well, Esri's take on a modern GIS is more than just mapping. It's a platform which integrates clouds, temporal data, AI, 3D, and also real-time data into one single system of record, insight, and engagement. It's turning location into the foundation for decision making. And how does imagery actually play a part in this? So we define imagery as the foundation of a modern GIS. It captures reality from satellites, drones, sensors, and it feeds directly into a system for analysis and decision making. Imagery turns GIS into a living reflection of our world. It's constantly being updated, measurable, and also ready for insights. And what better way of an example of modern GIS than a digital twin? a living, breathing representation of reality, not just showing what the past used to look like, but what simulates and plans what comes next. So in the past, maps told us what things were. And now with digital twins, they actually show us how things work, interact, and evolve in real time. So here is a good example of how Esri defines a digital twin maturity curve. We have the foundations of imagery. We have reality mapping. We have 2D, 3D visualization. And this is what a digital twin is built on. It gives us visualization and also documentation, but nothing dynamic. At this stage, it's like having a digital photograph of reality, fixed in time. As we progress, the next step is where things start to change. We start to bring in information. To bring this digital twin alive, we connect them with streams of fresh imagery and sensor data. So this could be satellite imagery with daily revisits, drone capturing of real-time videos, ground sensors tracking conditions, all feeding into one single model. Now we don't just understand what reality looks like, we can see what's happening right now in real time. And then we arrive at the final components: predictive, comprehensive, and autonomous. We can run simulations, flood events, traffic rerouting, energy loads, and feed these insights into the real world. With AI, the digital twin can also predict what's coming next. We've seen organizations and government agencies use it for crop yields, infrastructure stress, climate impacts, natural disaster planning. And at the most advanced stage at the top, we have autonomous. The twin doesn't simulate or predict, it actually adapts. So some examples of this are cities, which are able to reroute traffic if there have been accidents. Energy grids, where if there is a certain area which has gone down, they can rebalance themselves. And ports, which can reconfigure logistics in real time as and when needed. So for us, that is where we see the future of digital twins. Connected, intelligent, and eventually autonomous systems, all powered by imagery as its foundation. So this is an example where digital and also physical meet. And this is an example from a digital twin in the city of Slovenia. They're using flood simulation tools in ArcGIS to model heavy rainfall and predict waterfall paths to identify vulnerable areas in the city. And with this, the government is able to better plan when one of these events to occur and allow for faster disaster response. Another example is here in the city of Zurich. By integrating multiple data sources, the Zurich digital twin provides a holistic view of the city's infrastructure and also operations. So this powerful tool is being used by urban planners. It enhances operational efficiency and also improves public safety. It also provides the ability to predict future scenarios, monitor real-time data, and ensure that the city of Zurich can address challenges and optimize city management. So I wanted to close out this section by saying that sharing this recent industry report. These numbers show us something very simple. Is that digital twins have actually moved beyond hype. They're already being embedded in strategies, budgets, and also leadership priorities. The question is if they will be adopted, is how fast and also how well. And with this, I'll pass you over to my colleague Liz, who will share and also deep dive a bit more into our imagery capabilities and how we're applying this at Esri.
Welcome again to our Imagery Summit. So today I'll be talking about reality mapping and how we're enabling 3D GIS for government well, actually not just the government, but everyone that works on imagery that's coming from drone, aerial, and satellite. In this session, I'll start by sharing about reality mapping in JS. What is it? Why is it important? And why is it an important capability of JS? We'll then zoom into reality mapping at scale, what we mean by it, and also why it needs special consideration. Then we'll go over some of the digital photogrammetry that we're doing within JS, and a demo on Reality Studio and some of the exciting updates that we have right now. Okay. So first, I want to define reality mapping. So reality mapping is a key capability of ArcGIS that allows our users to create accurate digital representations of the world using images, LiDAR. And ArcGIS, we help our users through the reality mapping capabilities. So it's part of the broader system that you are all familiar with. At the core, again, we help you generate those foundational contents like the 2D maps and 3D maps from the individual images that you're bringing into the map space. So if you were here 2 days ago, you've probably shown some of the examples that our engine can do and how we can turn drone images, aerial and satellite images into photorealistic 3D meshes and highly accurate through orthophotos. And those products that we produce with the reality mapping engine is up to date as needed and can be as accurate as down to a millimeter in some cases, and it's ready and suitable for analysis. So it allows you to extract information from your imagery using, of course, ArcGIS platform to extract the metrics, identify changes, measure features, monitor vegetation, and even perform highly detailed inspection with the reality products. And this data comes into the JS and helps bring all of those photorealistic content that we have through a 3D intuitive application such as a scene viewer that can be accessible to a broader set of users.
好，那第次希望让大家稍微了解到，就是或多或少都有提到了ArcGIS Reality 在整个ArcGIS里面扮演的角色，就是呢，能够协助各位把各种多元的影像当作资料加以处理之后呢，它就可以成为各位经过分析之后的资讯，而这些资讯呢，就能够协助各位打造各种 GIS 的系统，协助各位在多方面的应用上面。
And by supporting multiple acquisition platforms, we offer a very great flexibility for dealing with different acquisition challenges. So we support generating 3D foundational maps from your drone imagery. So we know that drones can capture high resolution data and you can fire it anytime that your project needs it. But also there are the crewed aircrafts, which are very efficient and capturing large areas. So sometimes of a whole city or country. And so we support the processing of those images coming from those high-end sensors that you mount on a day, which can be 20 to 30 centimeters of resolution. But then also we have satellites. So we can generate 3D-based maps of remote areas that would otherwise be unreachable without significant risk, time or expense. So we support very high resolution satellite imagery. Those commercial products that are now available in the market, you can use that as an input into reality mapping. And ArcGIS Reality is a product suite. So it's a family of products that provides different tailored experiences. So let's start with the acquisition of your data. we actually have the capability to help you do your mission planning using our ArcGIS Flight, but also those images coming from your drone data capture, you can process them with either a drone to map or side scan, depending on if you want to process your images on your desktop or using cloud. Then we have the ArcGIS Reality Studio, which we'll get to know a little bit better in a little while. But this is meant to process images that are captured or acquired by those high-end metric frame cameras. And of course, we have the ArcGIS Reality for Pro. So this is working, doing digital photogrammetry in a familiar environment, which is the ArcGIS Pro. So this is an extension where you can process, an extension to ArcGIS Pro where you can process your drones, your aerial, and your satellite imagery. So it depends on the type of data that you're working on, how big is the processing that you plan to do, and at the same time, you can choose the suitable software that is meant for your data set. I want to focus today on ArcGIS Reality Studio. So this is our solution for large aerial surveys. So it's designed for citywide and countrywide mapping, and it's optimized for working with multi-headed metric cameras, those that are used in survey aircraft. So when we say multi-headed cameras, you have your nadir and your 4 oblique-looking camera. So your left, right, forward, and backward cameras. And this lets you achieve survey-grade accuracy for projects covering very large area. Now let's take a closer look at the outputs that you get from ArcGIS Reality. So first we have the 3D point clouds. So this provides you highly accurate representation of reality. You can do your 3D point cloud measurements, your point cloud segmentation, and feature extraction workflows with this kind of output. Next is we have the accurate 2.5D elevation model. So this can be used for topographic surveys, hydrographic analysis, and then we have the true orthos. So this provides you with a pixel accurate image layer. So meaning to say each pixel of the image is actually consistent with the elevation data, which is our DSM. And you can use it to perform precise measurements, light change detection, and this is a very important input for your GeoAI workflow. Lastly, we have the mesh. So this is the photorealistic carrier format for your JData. So it's very intuitive to empower those non-GIS specialists to interact with our data. You can integrate this with your existing GIS data or the other GIS marshal data that you have. You can overlay with the mesh. At the same time, we also produce oriented imagery. So meaning to say those, let's say individual images that are being captured by your drone, let's say in a JPEG format, Esri has a way of managing those non-linear images that we are acquiring. And also full motion videos. Sometimes if we fire up our drone and do our acquisition, we can also acquire videos together with our drone images, and those videos can also be managed within the ArcGIS imagery system.
快速帮各位复习一下Liz刚谈到的事情哦。首先，在 Reality Mapping 的制图尺度来讲呢，它可以支援从多种各同步的这种载具拍摄的高解析度或者是比较一般解析度的各式各样的影像。那各位呢，可以选择整个 Reality Engine 所打造出来的不同应用程式的整个家族里面的，看自己的需求来加以挑选。比如说呢，如果各位想要在云端作业的话，而且比较偏处理的是 你的无人机或者是空载飞机拍的影像的话 ，Side Scan 是各位可以选的。那如果你想要在个人电脑上面去处理无人机的影像的话，各位可以选用 Drone to Map。那或者是呢，你可以采用今天想要比较聚焦跟各位介绍的 Artist 的 Reality Studio 来做比较大范围的航拍影像的一个处理。那又或者是呢，各位比较想聚焦在一个比较整合性的操作的话，其实 Reality 也是 Artist Pro 的一个扩充模组。各位可以在里面呢比较统合性的来处理多元的资料，包括你的无人机，包括你的飞机，包括你的卫星影像，都可以在Pro 里面去进行处理之后呢，来后续进行 Pro 的其他分析工具的使用。而对于我们今天想要聚焦的 Reality Studio 来说呢，我们把这个产品定位在呢，能够协助各位在城市或比较更大范围一个尺度里面的大范围的航拍影像的一个处理。那它可以产出多种的产品这我们待会再说。那我们会希望在 Reality Studio 操作的最后中的结果呢，能够让产出的资料达到各位可以直接使用，也就是有一定的测量精度可言并且它也支援多镜头的航拍的结果。那除此之外呢，各位也可以在多台的机器上面安装 Reality Studio， 让他们在本地进行分散式的资料处理以提升资料生产的效率。那对于 Artist Reality 来说呢，它最主要的产出大概就是点云资料然后 2.5D 的地形起伏的资料，就是 DSM 的资料。那除此之外呢，影像部分会帮各位镶嵌成真实正色的影像，而各位也可以用这样的资料搭配之后呢，由Reality Studio 呢帮各位产出我们的 3D 仿真模型。那除此之外呢，个别你拍的照片也都可以成为 Artist 里面能够使用的所谓的定向影像就是这张照片本身，我们可以去读取它的拍摄参数之后呢，告诉各位这张照片所对应的拍摄范围之类的。那各位呢，也可以应用你的资料来源是无人机拍摄的影片来作为资料来源。那这个就可以搭配着我们的 Full Motion Video 的功能呢来编播影片这是在 Pro 里面了来编播影片，去知道说每一帧影片它所对应的拍摄的范围这样子。而这些背后的东西呢，就全部都是靠 Reality Engine 来去帮我们加以完成的。那例子呢，会接下来跟各位再做一下细部的说明。
Now this one shows how the complete workflow looks like within ArcGIS. So from your sensor to the processing of the data to how you can take advantage of the outputs that you have produced with reality mapping using the ArcGIS platform. But let's take a look at this aligned data, ortho DSM features, and the 3D and reality. So these are all the outputs and processes that you need to go through in order to produce your reality mapping products. And with your preferred solution, depending on the type of data that you have, you can still produce the same products with a reality. And I mentioned earlier about the oriented data. So when multi-headed sensors such as drones or sensors with 5 cameras acquire imagery, they take both straight down looking imageries that you can visualize on the map, as well as those non-linear or oriented imagery, as we call it in Esri. So this one can include your oblique looking images, your 360-degree imagery, street side imagery, images coming from your dash cameras, or inspection imagery, among others. And it may be hard for you to manage or visualize it and incorporate it into your GIS. So oriented imagery is the way that Esri solves that problem by providing a solution for managing, visualizing, and exploring images that are taken from an angle such as what you can see in this video. Now, just a little bit, let's say a bit of a closer look into the true ortho. So again, this provides a very pixel accurate image layer, and you can use them as an input for the JOAM workflows that you want to do within ArcGIS. So you can also perform different analysis using our imagery analysis workflow. And as I mentioned, the true ortho is an ortho-rectified image corrected using the digital surface model. So it removes the perspective distortion. There's no displacement caused by relief or null structures, resulting in no building need. So there's no obscuring of the ground features, allowing you to extract your information, the image, such as the building footprints are correctly identified. And of course, lastly, we have the photorealistic 3D mesh again. So the mesh generation itself, together with the true ortho, digital surface model, and the point cloud data, they are all a highly automatic process using and all powered by the Reality Engine. This highly accurate 3D point cloud data set, again, as I mentioned earlier, is ready for further exploitation with the 3D analysis tools that we have available in ArcGIS. So from the point cloud, we derive the 3D mesh, which we believe is the ideal combination of accurate geometry and detailed structure. So this makes it a very ideal canvas to present metadata, other geospatial data, and even semantics as well to provide additional context.
Can you go back to the first slide of this part? 好，那在Reality Studio 等等的这些软体的产出当中呢，如果各位使用的是中途 Map 或 Sidescan 或者是 Pro 的话呢，它就能够从最开始的资料的截取处理到最后的成品的产生。那以其中一项 Oriented Imagery 来说，所谓的定向影像来说呢，它希望呈现出来的效果是，各位可以在画面上面看到照片本身以及它对应的它拍摄的参数所换算出来的拍摄的一个范围框的指示这样子。那这资料来源呢，可以是你的斜拍的影像，或者是甚至360的相机拍回来的照片，甚至从 video 去截取，都是可以的。好，那另外呢，我们最主要的产出其实希望让各位能够得到真实震慑的影像。真实震慑影像希望达成的效果是呢，让每一个像素都像是从正上空去做拍摄一样。所以呢，当我们拍摄是一栋建物的时候，我们并不会看到它侧边的部分，就像你都直接从正上空往下看一样，不会看到建物的侧边。好，那我们之所以能做这样的事情呢，是因为我们会从各位的资料里面经过数位测量等运算之后呢，去换算出这些 DSM，然后用它来校准你的影像，去达成震慑影像产品的产出。好，那除此之外呢，这个也可以搭配起来，再产出为所谓的3D 的仿真模型。在3D 的仿真模型上面呢，也可以搭配着各位由你的真实震慑影像上面所萃取出来的建物框，再搭配上高层资料之后，产生的多面体去做套叠，让你比较精准的去了解到每栋建物所在的位置这样子。所以在这里呢，更正 Reality Engine 其实在背后会经过点云的运算，而这些点云资料会有来自于你的拍摄的资料所得的这个颜色等的数值。那组合之后呢，就可以帮我们产出这些3D 的仿真模型。那这3D 仿真模型呢，我们希望能够达到的是在测量上可以去比较精准的做我们的长宽高的量测，以及在材质的呈现上面呢，越接近真实世界的效果这样子。
And now that we have given you an overview of what reality mapping is, I want to provide more detail on how the Reality Engine inside ArcGIS and apply photogrammetric processing to your sensor imagery. So the reality engine applies modern photogrammetry to the image data to generate the true orthos, digital surface models, and also it's also referred to as the 2.5D, and of course the 3D data, which are the point clouds in the mesh. So when you apply ground control points and checkpoints, you can achieve a very high spatial accuracy, and we are able to make this a highly automated process. So in the lower left here, you can see the different ways again of the software products or the product family that offers photogrammetric processing. So in summary, this is a 3-part workflow, and the input basically will include your images, your orientation data, as well as your camera calibration parameters. It can be approximations or the accurate values if you have a sensor with stable sensor model. And the best practice that we recommend here is, of course, as we all know, adding ground control points to help refine the positioning and positioning of the output products with your design coordinate system to improve the spatial accuracy. The next step is the alignment process. So this is the error triangulation, where we refine the orientation data. So in the case of drones, it also refines the camera calibration parameters. And from this model, millions of 3D points are generated to form the raw point cloud. And this is also where you do the linking of the ground control points into the image input images to mark their locations. And further processing is applied is the reconstruction process to apply the refined orientation data and images to generate the dense point cloud. And from that, a digital surface model will be produced, then the true ortho and the 3D mesh. So just a little animation of how that's happening. So once you have captured the images with plenty of overlap, they are input with the orientation data into the software for processing. The reality engine will then again perform the alignment process by finding and matching distinct points across all images shown by these green lines, and adjust the orientation data to improve the accuracy. This then again process generates millions of 3D points, from which the raw point cloud and then further processing is applied in the reconstruction process to generate your output products.
好，那所以我们来谈一谈在ArcGIS Reality 里面的核心其实使用就是应用上的所谓的数位测量摄影测量这样的运算。那这个过程里面呢，其实快速来讲的话，大概经过这3个步骤首先就是呢，会需要各位输入带方位资讯的影像资料。那可以的话，你也可以选择性的输入相机的校准参数，然后呢去设定一些地面控制点。那接下来呢，软体本身就会利用这些资讯呢来去进行三角测量的定位等等的作业。那它也会搭配着你的相机参数，还有地面控制点来去提升它的精度，最后呢再做一个产出的动作。所以呢，如果我们用比较快速的动画来做解释的话，就是3个步骤，分别就是载入带有地理定位的比较高重叠度的影像之后呢，软体本身会去自动并且寻找匹配的特征点。那最后呢，经过换算运算之后呢，去喊出前面我们谈到的那些 GIS 可用的产品。
Okay, now let's take a look at the software. So I'm going to do demonstrations here to introduce you to the ArcGIS Reality Studio. So again, ArcGIS Reality Studio, we can use our aerial images captured by those parametric cameras. And this is a quick tour of Reality Studio. So the workflow in Reality Studio starts with the import of the image positions as recorded during the photo file. And you can see from the screen here, the individual camera positions. And additionally, you need to provide a link to the aerial imagery, which should be available as a GIF or a JPEG, as you can see here. The third component of this is the properties of the sensor system. So this needs to be passed into Reality Studio. As you can see here, we have here oblique sensor called IGA urban macro, which consists of 4 oblique looking camera heads and 1 looking nadir frame. So you can set the camera parameters, or you can use the template as an input in Reality Studio. So with these 3 ingredients in place, Reality Studio now builds a capture session, which typically represents 1 individual photo flight from takeoff to landing. The capture session is also accessible via the status or screen, so from where additional features are available, such as creation of a dynamic ortho. So here, what I want to do is to produce a dynamic ortho of the nadir camera session to help me assess the image quality even before starting the actual production. So here I can clearly see that my photos are aligning nicely to the globe. Now, once we're done with that, we want to next proceed to the alignment process. So having 1 or more capture sessions created, you can move into the alignment or image manipulation. Again, this is the step required to refine the quality that you initially provided in your image positions so that we can pass the most accurate input into the reconstruction step later on. So for now, let's switch into a pre-processed alignment session. So Reality Studio, we provide a complete, comprehensive error triangulation workflow. It is a very robust alignment approach, including automatic time point matching to link individual overlapping images, even manual point measurement tools, as well as quantum block adjustment engine. But I'd like to focus on 2 aspects here: the measuring of the ground control points and an option for you, the user, to analyze adjustment result. So let's take a look at how you as a user can measure ground control points using Reality Studio. What I want to do next basically here is to open my image measurement tool, such as this one. And in here, on the left side, you will see an overview of all of the GCPs a user has imported. And the good thing here is that we can sort out the GCPs to check which GCP we have yet to measure. And of course, on the right side, once that sorted, we can immediately see the list of corresponding images to which we see the GCP that we want to measure. So in Reality Studio, we need to take 2 initial measurements. And once that's done, we can use the Find Suggestion option so that we can transfer our measurement to all of the remaining images, which works very fast and reliably for nadir and oblique looking images. So as we can see here, we're able to find 29 over 55 images that are matching. So the next thing we can do is to accept the suggestions measurement and double check the other images that did not see a match as part of our quality assurance. So here we can see that some of the points actually are overlapping with trees, preventing the measurement. And now with the sufficient amount of GCPs measured, plus the automatic measurements in place, we can now kick off another refinement, bundle block adjustment, in order to assess the results of this step. Also, Reality Studio comes up with a quality assurance tool. So this will give us a general idea about the project and how well our alignment has performed. You will see your detailed insight into the most important statistic parameter during the alignment process. So the statistics that you see here can be linked with the corresponding graphical representation in the map view. So here we can see the time points polarized by their mean or projection error, which matches their respective histogram. Of course, further details can be extracted from the results table. So you can do a detailed inspection of the alignment. As I've mentioned, this will affect the quality of the reconstruction, the production of the true orthos and the 3D mesh. So this is a very important stage in a photogrammetric workflow. Now, what I want to do next is to potentially delete some inaccurate measurements as needed. So you can also do that with Reality Studio. So here, you can basically just sort the results and find the inaccurate measurements. Help me better understand how well the alignment process performed. And as soon as this alignment process fulfills any project requirements or specifications that you have, we can now move on into the last step of the reality workflow, which is basically the reconstruction. But what I haven't mentioned or failed to mention earlier is that Reality Studio is also able to do distributed processing. So meaning to say, if you have a production setup with the licenses installed, you can use it to improve the processing time. And setting up this reconstruction workflow is quite straightforward, as you can see here on the pre-process session. So we can look into the reconstruction settings, and as a user, you simply have to select the processing scenario, whether to use your oblique or nadir data, your input data, and also the desired output products that you have. Additionally, you can also pass an area of interest or a 3D body, a water body shape can be added. So the 3D water body shape file, it's very useful as it helps you flatten the water surfaces in the output products. And typically, our users deal with a fairly large areas and class amount of data. So it is very desirable to speed up the production. And to do so, ArcGIS Reality Studio will set up the process in a way that you as a user can every time add an additional processing node to contribute to that process. So a node simply needs to have the ArcGIS Reality Studio installed, and it needs to have a shared network drive where the processing results can be tracked and collected. So I'll also share with you how we can easily do that with Reality Studio. So what I want to do is to now go to a pre-process session where we can review the product phase and also have a second reconstruction set up so that we can distribute our processing. So distributed processing is very ideal if you're working on, let's say, a city scale or a country scale. So Reality Studio can process up to right now 65,000 to 70,000 images, all in one project. And ideally, we have multiple workstations available to process that. So this is an example of the distributed processing. This is my workstation 144, and what I did here is to add a new reconstruction. It's very simple. Once I've added the reconstruction, I simply have to click the submit button and submit the reconstruction to a cluster. Once that's done, it will now be connected to the nodes that is waiting to pick up reconstruction jobs. Now we can start a contribution, which means the workstation 144 can now act as a processing node and can pick up jobs, which we can now see from this workspace monitoring. Then I'm going to add this workstation 111 and second workstation, which also has ArcGIS Reality license. What I want to do is to have this workstation contribute to my distributed processing. So here, I just need to specify the workspace folder, and with that, this workstation 111 can now pick up jobs. And you're not limited to 2 machines. You can continue adding machines to contribute to your distributed processing. Once that's done, you can now see that these 2 machines are now populated on our monitoring workspace. And the beauty of this, again, is that you can add more workstation to help with the distributed processing. So this is what it will look like once you do your distributed processing with Reality Studio. The green tiles represent areas that are now completed, whereas the blue tiles are still processing. Once you're done with that, and you can monitor your workstation or the workspace in the multiple machines that you have as well. Once that's done, everything will now turn into green tiles, and you can easily check your output within Reality Studio, or even open your project in ArcGIS Pro.
我大概快速的讲这个软体的一个操作的流程跟过程，因为 Reality Studio 最主要是处理比较大面积的航照影像。那它接着下一版，它也会支援无人机的影像，直接去在 Reality Studio 去处理。那我们首先，它在第一个阶段，基本上第一个 session 就是把影像资料汇入进去。那当然，如果是数值航照的话，我们还会提供那些航照的外方位，就是 frame table 跟 camera table， 就是外方位参数跟那个相机参数的部分。那接着会导入到下一个步骤去做空三平差的一个，就是它的 alignment， 就是那些影像对位对齐。那在这里呢，我们自己尝试过用无控制的点的产制，其实在你的影像 overlay 够好的状况之下，它的精度其实都已经符合我们一般的测绘使用。那如果你要更高精度的，当然就会再加入控制点。那刚刚在影片中其实也有加入控制点去做控制点点选，去新增控制的部分。那在那部分你也可以把一些控制点变成检核点。那这如果是大家有在做正式影像处理的流程，基本上都是一样的。只不过它现在 Reality Studio 透过Reality Engine， 它后面产制的 DSN 还有 Point Cloud 点会 让我们之后的产品的精度会更精准、更正确。那才会刚刚在 Reality Mapping 的介绍里面都有提到，我们的那一些高差位基本上都会被纠正到正确的位置。然后在很多的 Auto Type Point 就那种自动共二叠产生的部分，那因为各影像的匹配，我们可以产生非常多的 Type Point 来让我们的精度更好，然后也可以让我们的产品就在 3D Mesh 就三维的模型或者是高层 DSM 的模型都能更精准。那当然，因为在大范围的资料处理，如果我们只用一台机器在处理的时候，其实我们要等很多的时间。那所以我们这个都加入了那个分散式的运算，我们可以在一台工作主机上把整个专案设计好之后，然后把这个价本分享出去，然后我们在其他的主机上当然也是要有 Reality Studio 的 license， 那它就可以用其他台的机器一起来帮我们把这个专案整个把它运算完，然后产制产品。那最后的时候，其实我们看到那些一个一个的那个 tile 一块一块的，它基本上就是把一个大的专案会分成很多区块。那如果你有假设它现在有10个区块好了，然后我们有10台工作站的话，我们可以让10台机器同时把整个专案把它算完，这样可以节省那个资料处理的时间啊，大概是这样。
Okay, so now let's go to some of the exciting updates on what's coming and what's new on ArcGIS reality. So first is that with the new ArcGIS 3.5, you can actually now create LOD2 models using your digital surface model and your building footprints. So you can create LOD1 and LOD2 to capture the slope and directional orientation of the roof of your buildings. So I encourage you to, if you have access to ArcGIS Pro 3.5 and you've produced your reality map products, your DSM, and your building footprint, you can go and try this new feature that we have. At the same time, in Reality Studio, the software that we just saw earlier, you can also do some mesh editing in the application. So sometimes the data is not perfect, right? So in the new release, you can now edit 3D meshes directly in Reality Studio. So you can draw a 3D correction geometry to correct artifacts such as holes in your building, such as this incomplete building facade. And once you have defined the geometry, it can be specified in the reconstruction setting, which causes the reprocessing only of this affected area. So this enhances the overall quality of the mesh products that you are producing with Reality Studio. But sometimes, okay, so let's just finish this video. So again, once you have defined this correction of geometry, you can now save it and then add it into the reconstruction. Once that's done and pre-processed, you will now have complete building facades such as this one. Sometimes also our users are editing meshes using external tools. So you can now edit the surface of surface geometry for 3D mesh with an external editing software. So you can mark up the areas that you want to update using this new quality control geometry. It generates this editing packages, and using the new quality and using these packages, it can be opened in an external mesh editing application, such as Mesh Mixer by Autodesk, for a detailed modification or manual editing of the object. So you can use this to remove unwanted corners or add some missing features, and then incorporate those edit packages back into the entire mesh. So again, once edited, packages can be imported into Reality Studio where the reconstruction processing takes them into account, such as this one. So this is very ideal for those that prefers to use things 3D objects or use a preferred external application for mesh editing. At the same time, there are cameras or what we call hybrid sensor that has both the camera, the oblique looking, the nadir, but at the same time, they also acquire LiDAR data. So we now support using LiDAR data as well as an input into Reality Studio. We have added this support for LiDAR, especially for areas that are occluded, with lots of transparent buildings, reflective buildings. So the LiDAR helps produce a higher quality mesh and make sure that those areas that have reflective buildings or occluded parts are reconstructed with higher quality. It can also be very helpful in areas with shadows as well as for lights that have less overlap. So here you can see the option to add your LiDAR data into the reconstruction processing. And this will have significant results as well, the quality of your 3D mesh. Lastly, to add some more life improvements into the way we work with the product, we have added this multiple views into our image measurement tool. So it now allows you to adjust the layout from not just 1, 4, or 9 images simultaneously to make it more efficient for you to place your ground control points and review the measurement suggestion by the Reality Engine. So here you can view again in 1, 4, or 9 and visualize how points are located in different images. So it makes it easier for you to review the available measurement suggestions. An exciting update that we have, and for those that are here 2 days ago, they already know that we're also adding Gaussian splat into the mix. So now you can produce Gaussian splat with the upcoming release of ArcGIS Reality this coming November. So Gaussian splat represents the world as millions of overlapping splats, like tiny transparent ellipses, and this splats captures both color and position, allowing the computer to render a scene that looks very photorealistic, but also very detailed. Let's take a closer look at the use cases for Gaussian splat. So this is very ideal for modeling vegetation in fine detail. It provides an immersive viewing of reflective and transparent surfaces. And also, it makes it, or it renders those thin and complex structures very nicely. So this is ideal for, let's say, construction sites or infrastructure monitoring groups, such as this one. So this is a Gaussian splat captured by drone imageries using the shared UAV multi-headed drone sensor. At the same time, we also did this proof of concept with our colleagues in New Zealand. And here they flown the area with both LiDAR and also acquired some drone images. So here we just extracted the buildings from the point cloud, but also we use our drone map to produce mesh. As you can see here, we have some gaps in the mesh, but the Gaussian splat is able to reproduce or reconstruct this area very nicely. The mesh is powerful, but sometimes it struggles in those parts. At the same time, with the upcoming release, you can view your Gaussian splats into ArcGIS Pro and also conduct measurements And at the same time, the Gaussian slots we are producing is georeference. So meaning to say it can be in your local coordinate system, and you can overlay your existing GIS data, like these utility networks that we have, to provide further contextual information for your planning, your monitoring, and of course, the decision making. Here's another example as well of a beautiful showcase of an industrial zone with many complex steel structures. And it seems like it's a video, but actually it's a Gaussian slot that produced by the same engine, the reality engine that we have. And here's a great local example. So here we're going to be showcasing some 3D mesh and Gaussian slot of Taiwan's National University. So it has been captured by a drone sensor with 5,445 images and an overlap of 1440. So the resolution of the image layer when you see is 1 centimeter, and it has been processed by ArcGIS Reality Studio. So here we can see now the comparison between the 3D mesh and the Gaussian slot. So as I mentioned, the mesh is a great output of reality mapping, but it can sometimes struggle with the team structures such as in this complex construction site. So as you can see here, we have some holes in the mesh is looking a bit melted, but the Gaussian slot that Thomas has produced just days before this event, we can see how well the engine is actually reconstructing those team structures that's present on this side. So Gaussian slot is a perfect complement to use alongside your 3D mesh, especially for these areas, for monitoring or modeling the thin and complex structures that's required for your work. Here's another example. So you can see the pole here, that the mesh is failed to reconstruct, but it's present with our Gaussian slot. And overall, the Gaussian slot is very useful for infrastructure maintenance, for construction monitoring, asset inspection and management, and even utility inspection, among others. I encourage you to work with our colleagues at IDT if you want to find out more about this very impressive technology that's coming to ArcGIS this November. And I just want to end with this beautiful drone flight with a 2 centimeter ground sampling distance that illustrates the capacity of handling complex structures, fine infrastructure, vegetation. And again, we are adding this as part of the reality mapping product that you can produce both from our reality studio, which is a solution for those high-end cameras, but also within ArcGIS Reality for Pro, so inside a familiar system to all of you, and even our drone products, the drone to inside as well. So this will further leverage the web streaming experience, and you can render large-scale geospatial data set. And we're really focusing on expanding the 3D capabilities, our 3D GIS capabilities of ArcGIS. I just want to end with this one slide. So you've just seen 10% of what ArcGIS can do, and there's really more into this powerful technology. Thank you very much.
好，那快速帮各位复习一下Liz刚刚谈到的一些 Reality 上面的新的功能，包括说，如果搭配了我们的3D 分析的模组，各位呢可以从这些仿真模型跟你的 DSM 或者 LiDAR 资料上面呢去做到LOD2 层级的建物资料的萃取。那除此之外呢，各位也可以在软体里面呢直接针对觉得3D 仿真模型比较不好的面的部分呢，把它框起来之后呢，由软体去重新做计算，甚至于你可以把一小块范围把它挖掉之后呢，在那个地方摆上替代的建模的模型，然后让软体从你的仿真模型里面去萃取材质，再贴回那个模型上面去， 来替代成整个仿真模型的细节的呈现。那除此之外呢，我们也提供了LiDAR 资料的处理的部分。那在 Reality Studio 本身呢，也多了Gallery View， 就是可以同时展示4张或9张、16张照片等等的这样的呈现方式，让各位可以去比较同一地点不同的拍摄的影像。那除此之外呢，最新的就会是即将在11月，我们会在软体里面加入这个高斯波键的功能。那高斯波键的特色其实就是它可以让我们的仿真模型的细节的部分呢，能够更真实的去做个呈现。那以这样的情境来说呢，比如说如果你要呈现植物的一个分布的话呢，它可以比较清楚的看到植物的叶片的部分之类的。然后如果有一些建物上面呢有反光或透明的材质的话呢，仿真模型比较没有办法清楚的表现出来，而高斯波键的模型是可以的。那我觉得更重要的就是呢，它在一些建物的细节上面的呈现会更漂亮。比如说在一些鹰架的部分可能我们在仿真模型的部分呢会看到有缺陷的存在但借由高斯波键的加入呢，我们就可以呈现出比较完整的管线的资料。那这个例子的话呢，其实就是纽西兰的公司呢使用了高斯波键模型之后呢，把原本的3D 仿真模型把它替代成为用高斯波键的模型去呈现一个变电所的细节。所以各位看到每一根电线每一个那个爱子都可以比较清楚的去做呈现。而这上面呢，也是可以实际上去做一些量测的作业的。那除此之外呢，它是有地理定位的资料，所以你甚至可以套上你的管线资料，来搭配去进行管线相对应的分析的工作。那这个例子是直接用仿真高斯的波键的模型去呈现一个动画效果出来，所以这些细节的铁架的部分呢，各位看到都蛮清楚的，可以去做个呈现。那本身我们也借由合作伙伴那边拍摄的宜兰大学的无人机的影像大概5400多张的照片，然后用 Reality Studio 去加以拼出这个模型出来所以左边的是仿真模型的部分，右边的呢则是高斯波键的模型。我们可以看到一些鹰架上的铁条的细节呢是比较明显的然后呢在屋顶上面可能左方的3D 仿真模型，各位并没有办法看到一个比较完整的旗杆在屋顶上面但右方的那个屋顶的旗杆的部分呢，有比较呈现出来。而像下面的那个储水槽的部分呢，它的管线的细节也比较容易能够去加以呈现。那最后的话呢，这个是一个2公分解析度的无人机影像所拼出来的一个球场，然后其实就可以更真实的去呈现一个样貌。那Liz刚好提到说这些东西接下来呢都会整并到我们的Reality Engine 里面，陆陆续续的在多个应用程式里面提供给各位加以使用。那如果各位后续对相关的技术想要多一点了解的话呢，欢迎跟我们的业务同仁联络互动的技术团队会很荣幸的能够去各位那边来跟各位比较详尽的来介绍这些技术细节的部分。谢谢例子。
Should I proceed?
I think you can proceed.
Okay. Okay.
好，那例子还有一份投影片我想请他快速的跟各位介绍一下。
Okay, so now that we have created our foundation for digital twins, let's see now what are the different patterns or workflows that we can use to make use of those data sets. But first, before I do that, let me give you an overview of where reality mapping fits into the entire imagery remote sensing capability of ArcGIS. So ArcGIS today is a comprehensive imagery and 3D system. So it is scalable. It's an end-to-end solution that transforms imagery from pixels into actionable insights. And our work in imagery spans across 5 different pillars. So we have the management. So basically, this is us managing all of the images that you're acquiring so that you can give access to those who need it. We've seen reality mapping already. We have analysis. So we have a lot of different image analysis workflows that you can do with our image analysts, 3D analysts. But at the same time, we have over 100 different pre-trained models that you can use for JOAI to jumpstart on your JOAI workflows. And of course, we need to communicate the information that we are getting from our imagery. And we have different visualization tools that you can use to create applications, dashboards, story maps, among others, to share the information that you have acquired from your imagery. And this is one great example of how managing your images using the ArcGIS imagery system look like. So here we see a quick example of, again, what's possible when I manage my imagery, my geospatial assets within the ArcGIS system. This is what we call the content management dashboard. So it's a powerful way of monitoring and managing geospatial assets, including your imagery, by publishing a catalog dataset. Organizations such as the organizations that you're a part of, you can view key insights in your organization's enterprise asset. So this can provide information and data type breakdown, storage usage, ownership, and access permission. So you can quickly and easily search and filter by layer type, by publishing date, by storage size, or even by user, making it easier for you to find the data that you need, the data that you have in your organization that you need. Such as this one. So I'm looking for an image scene over red rocks. It's a beautiful 3D image that, my colleague has created with the reality engine. And I can easily just, use keywords, and it will open up this page where I can easily access the data, whether ArcGIS Pro or online. I don't have to download the dataset. I can just stream it because all of those are being managed within one system. So this dashboard that we have, this helps you stay organized, optimize your storage, so you don't have to collect multiple images and make your imagery investment worthwhile. So having this dashboard and managing your images gives you full visibility and power over the imagery that you are paying for, you're acquiring, and you are investing on across your enterprise. And of course, your colleagues at IBT can help you, understand how this process can be created for your organization. And since you've already seen reality mapping, I wanted to share more on how we scale with your needs. So from a single site to an entire region. So whether you're capturing a building site, campus, or a dead city, we have support for the creation of 3D foundational content for digital twin at every level. Let's take a look at how we are delivering this using our drone reality mapping workflow. So in this project, we're showcasing reality mapping from drones within the ArcGIS Pro. So you can see the different flight modes that can be captured using ArcGIS Flight, including crosshatch, vertical, area-based flight, and each one is optimized depending on the purpose of your drone surveying project. The drone imagery that you have acquired can then be processed using ArcGIS Reality, the extension to ArcGIS Pro, to create again those reality mapping products that we've talked about earlier, such as this VSM, the True Ortho, So this digital surface model, again, that we saw in Reality Studio, but not inside the Pro, the true orthophoto, and the photorealistic 3D mesh. But in the familiar ArcGIS Pro environment, so in creating that rich visualization and analysis, and using these images acquired by drone, such as the oblique shots, you can generate now the oriented imagery data. So this oriented imagery layer, it complements your ArcGIS reality. If used together, it provides a detailed view of what's happening on the ground. So in this case, it can support inspection, providing a more remote intelligence. And at the same time, I've also mentioned that drones can also acquire videos. So the beauty of this is you can also incorporate your motion imagery from drone for a dynamic field inspection, all within, the ArcGIS Pro application. So we are basically taking advantage of every imagery that you are capturing in the field. And the JPEG that you're seeing here, it is being zoomed on the full resolution in the individual images captured by your drone. Now here is the example again of the full motion video that can also be captured by your drone data. Once again, providing the dynamic field observation and providing you with more information about your project areas. And all of this foundational content, the 3D mesh, the true ortho, the oriented imagery, can be integrated into a custom no-code or low-code application like the Experience Builder. So here, our customer built this remote inspection application with the Experience Builder. It combines an inspection checklist with an interactive view of the site, allowing you to automate, create points of interest, and share updates with the field teams in real time. So this is the end-to-end workflow that can empower you to visualize and inspect and manage infrastructure from anywhere. Starting with your drone imagery, reality mapping, to again, the visualization tools that we have within ArcGIS Pro. Now, for those of you, but also, here's also actually a very nice example of a 2 centimeter resolution 3D mesh of the Alcatraz Island. So this has been, the flight has been done with ArcGIS Flight. We've captured around 2,600 images, and the photorealistic 3D mesh has been processed with the site's software as a service for drone processing. And just another quick example. So this one is actually the building E, the Esri campus. So we've conducted regular drone flights during the construction process. And as you can see, we've also produced the true orthos at the same time, manage those imageries with the ArcGIS image system, and we are able to view the temporal visibility that is very essential for planning, inspection, and understanding the different stages of the construction project. Again, we have also this beautiful view of Tokyo rendered with ArcGIS Pro online and captured with a area survey mission and processed with reality. So you can see here the new features that we talked about earlier. We can run our JWA workflows, conduct analysis of our digital surface models, and even create those LOD2 models for the combination of the digital surface models and also your building. So it's all packaged in this very nice experience builder, allowing you to interact with your data in a context of photorealistic 3D canvas. So really unlocking the power of that 3D GIS that we talked about. And lastly, here's a very nice visual digital twin that is made out of Airbus Pleiades Neo satellite imagery. So this is your 30 centimeter and 50 centimeter satellite imagery by Airbus. And we have produced this high resolution 3D mesh over Tokyo. So this photorealistic model offers as well not just a visual that can be used for urban planning, risk assessment, and infrastructure monitoring. So for those customers that are like using, drones, aerial, this could are focusing on acquired satellite imagery. So this is now what's possible when you use those imageries within ArcGIS Pro together with the reality engine. And to further,
好，那快速的来讲一下哦，Liz刚上半段在解释的内容哦。我们利用 ArcGIS 这个完整的系统，我们说一个平台哦，其实可以把各位的影像在多方面来加以使用。那它这 part 比较强调的是，我们可以利用 ArcGIS 来协助各位去进行影像资料的管理。哦，那实境制图当然是作为资料产出的其中一环。哦，后续要做分析或者是单纯来做资料呈现，哦 ，ArcGIS 也是可达成这样的内容的。那以资料管理来说呢 ，Liz 刚打开了一个网页，哦，它示范了怎么在既有的 ArcGIS Portal 里面搭配着我们新的 Catalog Layer， 在这上面呢就可以协助各位管理多种不同的服务来源的图层，然后你可以了解到在不同的区域内各有多少数量的该类型的图层。那如果你要切换去分别看到它背后所占用的储存空间，或者是目前的使用人数等等，这些其实都能做到的。而借由查询界面，哦，各位可以快速去选出自己所需要的图层之后呢，无论是你要把它在网页上面做呈现，或者引用到 ArcGIS Pro 上面来作为你的图层之一，哦，那这些呢都可以让各位的影像价值呢得到最大化，不会需要每个人都存了一份影像，哦，可是可以在多种不同的装置上面去引用它来使用。好，那另外的话呢，实境制图的话，在这边它给各位看了几个范例啦，那从最小的场址到比较大的一个区域来说，比如说这边的例子就是透过Reality Mapping 的扩充模组，在 ArcGIS Pro 里面呢，我们可以去做无人机影像的资料的读取，然后呢，去直接在 Pro 里面去进行真实震慑还有3D 仿真模型的操作。那这些东西呢，都可以在后续的分析里面成为各位资料的来源，而且每一幅单张无人机拍摄的影像，因为带方位资讯都可以成为所谓的定向影像，而提供各位一个检视的界面，不论是在 Pro 或者是在各位的 server 端，就是网页上面做呈现。那如果在 server 端来说呢，甚至各位可以搭配着一个图台的开发，让这样的影像可以成为你去做，比如说水坝的监测作业，填写资料的时候一个判断的依据。而本身在从事这个作业的人，也可以切换到3D 的模式，从3D 的视角去了解到说，这张照片是从哪个方向拍到水坝本体去的。那接着他在填写一些报表资料的时候呢，都会可以更精准的来去完成这样的作业，而人不用实际到现场去完成这些工作。那这个例子则是2公分解析度的影像去拍这个恶魔岛的部分啦。那恶魔岛的话，如果各位跟我一样有看过《绝地任务》尼可拉斯凯奇跟史恩康纳莱演的那部电影的话，就是这里。是。好，那这些影像呢，如果各位是多时期拍摄的，在 ArcGIS 的环境里面，我们可以让各位用时间轴的方式来加以检视，所以你可以了解到，在一个工地它的不同建筑的历程里面，真实状况的施工进度的掌握。好，那这个例子的话呢，则是东京的例子。好，那最后这个例子的话呢，则是用卫星影像的部分呢，来去产制这个真实震慑的资料的内容。
Talk about ArcGIS and how we support the entire geospatial AI lifecycle. They can now use ArcGIS Pro to access those images that we have produced at the start, label and prepare them, prepare the training data, train the deep learning models, and deploy and consume those models to run inferencing at scale. And there are two ways that you can be successful in GeoAI within ArcGIS. So first is we help our customers be successful by creating and making available more than 100 pre-trained models that suit different business needs and applications. So you, as our customers, you can immediately start using them. So you don't have to start from scratch and do all the hard work of collecting the training data. So having the required community resources or even having, the extensive AI knowledge. So you can already take advantage of this existing pre-trained model that we have. But you can also retrain, create your own model through the Deep Learning Studio. So this is a web-based application on top of our image server, first available through the ArcGIS Enterprise, designed specifically to make deep learning workflows easier for imagery analysts who may not be Python experts. So it provides you the interface for labeling, training, inferring deep learning models on your imagery, and run your GeoAI workflows at scale. This is also a very collaborative tool. So for those of you that are working on a bigger area, this is a very ideal application for you. But then also we can see below that this pre-training models, this GeoAI models that we have works very effectively with our reality mapping product. So whether that's your point cloud, your DSM, your true ortho, and also your 3D mesh. And we're seeing that, from any imagery through your digital surface model and your true ortho, with the use of GeoAI, this is really providing us the new era for mapping. And this example here that I have is from the government of Cantabria. So it's a great example of how organizations are modernizing their topographic mapping flows. So they are one of the first few to adopt GeoAI for their topographic mapping. They start by acquiring this high-resolution aerial imagery across the region of Cantabria. That imagery is then processed with ArcGIS Reality, using the highly accurate true ortho that you are seeing here. Every pixel is aligned. And then these true orthos, they are just visualization products. So again, they serve as critical input for the GeoAI workflow. So using the machine learning, Cantabria government automated their feature extraction and they directly fed it into the map production. So they dramatically reduced the time from image acquisition to the final map production by accelerating the entire cycle of topographic mapping, increasing their efficiency across the board. Of course, this is also another great example of how GeoAI is transforming disaster response. So using imageries captured by drones and producing, of course, reality mapping products such as true orthos, DSM, coupled with GeoAI, we can automatically detect and classify cars, debris, and structural damage within hours of a disaster. This is actually the flooding that happened in Valencia, Spain, and our colleagues from Esri Spain, this GeoAI fired up a drone to help the government in this critical recovery work. And we are not just limited to 2D, but now you can also apply GeoAI workflows and detect objects from 3D point clouds and your 3D meshes, such as this one shown from the screen. So this is really making mapping more autonomous. So the reality mapping products, again, there's best input for GeoAI object detection. The true ortho and ESM, they are ensuring the precise geospatial analysis. So any objects can now be extracted, segmented, analyzed in both 2D and 3D. So that's really the power of location amplified by the power of automation to create immediate impact. And as Johannes shared this slide earlier, so 3D GIS is now integrating with digital twins. And reality mapping is the foundation to capture the snapshots in the real world. So together with the enterprise GIS, the open data, and real-time feeds, we are now building this modern GIS. So it's not about building one thing well, but it's about building the right foundation so that many things, many digital twins can grow from it. And with Esri, you can create your own personalized digital twin. It starts with your visual-based model that's produced through reality mapping, as we've talked about during the first session. Then, by adding the tools and capabilities of the ArcGIS platform, you can shape it into your own version of digital twin, tailored to your needs, powered by the wide range of applications that we have and clients that we have available in ArcGIS. So remember, there's no single path to a digital twin, and each organization's journey is unique.
那在这 part 的意思想跟各位谈到的是呢，如果reality mapping 的成果在搭配上具有 AI 之后呢，就可以协助各位的去完成比较快速的制图的作业。所以如果各位想要这么做的话，目前有2样的方式。一个的话呢，是各位产出这些影像之后呢，可以直接从 Living Atlas 上面去下载已经预先训练好的深度学习模型，然后直接用它来判识你的影像。又或者是呢，各位可以搭配着 Portal 上面的Deep Learning Studio，把那个预训的模型当作基础，再从你本身的影像上面去产出新的样本之后呢，进行模型的再训练，那就可以让各位更精准的从你的影像资料当中去萃取出这些资料出来。所以我们的影像的特色当然强调就是真实正色，所以如果搭配上9AI 之后呢，我们去产出来的每个 feature 其实位置都相对来讲是很精准的。那藉由这样的作业呢，我们就可以把把实境制图产出的影像资料呢，转换成各位实际可用的 GIS 图帧，然后用在各位后续的各式的分析工作上面。所以如果你搭配上9AI 的模型的话，以前可能需要人去这个场地面去做一些物件的测量，现在只要有影像加 AI 模型就能够完成。那这样的模型呢，其实也可以用在 3D 的仿真模型上面，然后比如说在这里我们可以试着去找出一扇一扇房子的窗户出来，是用 AI 帮各位判识的。然后真实正色产出的影像可以直接的匹配到对齐到各位的既有的 GIS 的资料上面，而且也可以像刚刚一样做那个直批的判断。那Johannes也有谈到真实正色可以实境制图呢可以作为数位双生的一个资料基础，那就可以整合出我们的 3D GIS 出来了。那在这里呢我们就可以借由 ArcGIS 来完成这样的作业，并且让各位的这个Digital Twin 用在你自己想要去进行的都市规划啦环境管理诸如此类的不同的作业上面。那整个概念就会是呢，以实境制图为基础，搭配上9AI 或者是 ArcGIS 的其他的工具或功能来打造你自己的数位孪生之旅。在这个数位孪生里面呢，因为每个单位的需求是不太一样的，所以可能没有既定的路线。那如果各位需要一些技术上的协助的话呢，我们也很乐意的能够去跟各位进行一些交流。
Okay, so the last one of my presentation, let's just take a few real-world examples of how our customers are adopting digital twins across different skills and use cases. So let's now go to Nottingham in UK. So they have been in the forefront of using digital twin to their CV for the review of major development application. So the city of Nottingham built its public development portal using a complete ArcGIS workflow. So they started with ArcGIS Reality, which of course transforms aerial imagery into those highly accurate 3D mesh of the city. And this 3D data then is used in ArcGIS Urban. So allowing planners to visualize proposals, upload models, manage projects, creating a 3D system. Next, they publish it to a scene viewer, so enabling 3D interaction directly into the browser. And finally, everything is wrapped into this public-facing application using the ArcGIS Experience Builder. So enabling the citizens to explore projects, track the development or planning status, and also access key details about the different projects. So this is how it looks like. So this is the Nottingham City Council's development overview map. In this portal, you can explore the city's major developments, visualized in 3D, overlaid with categories by development status, such as granted permission, under construction, or complete. So each project here directly is linked into the detailed planning information. So for example, in here, you can go to a specific area and you can check the planning information where you can access the site plans, design models, approval documents, and timelines. For example, this residential area in Queens Road. So let's take it. And then here we see the information I've mentioned earlier. So the approval documents, timelines, design models. So this helps city officials to not just manage the development at scale, but also keep the public informed in a visually engaging and transparent way. And then also there are new ways to experience this digital twin. So this is the ArcGIS Maps SDK for game engines. And this is a newly released ArcGIS Urban XR add-on. So it allows you to strip into this massive data set of ArcGIS into a more immersive game engine environment. So it provides you access to the information models and scenarios for a more subjective assessment. So placing you, for example, as a decision maker on the virtual street, so that you can walk down this street to understand the trade-offs between the variations that are submitted for this proposal. So here you can walk down the street and understand what are the changes happening based on the proposal that's been submitted for this part of the city. And then let's look at some campus examples through this Esri headquarters. So here we begin with the scene viewer. We've combined it with the 3D mesh of the building E and the 3D GIS data of the Esri relevant. This scene also includes a time series of the meshes produced at different times during the construction progress of building E from 2018 to 2021. What we want to do next is to overlay here the Revit model of the building onto the mesh. Basically comparing as is with as designed to visualize and validate the built environment alongside the proposed design. So now that we have the Revit model, we can also use the what we call Building Explorer. So we can navigate through the different construction phases of the floors, explore architectural, structural, and electrical components along all from within the web interface. And then we can then also now switch into some high resolution cloud data. In this same area of the building E, to show not just the background features, but also the location of the underground utilities. So this view enhances our understanding of the subsurface environment. This is very critical for planning and maintenance and empowering a smart cities facilities management. So here we can slice through the ground and see the existing underground assets that we have. I want to take you back inside the building E, where we have integrated ArcGIS indoors with indoor scans. So here, again, we've integrated ArcGIS indoors with indoor scan, capturing this highly detailed indoor environment. So once processed, these scans can be exported as LAS files using the ArcGIS tools such as generate floor plan from your point cloud. We can extract 2D floor plans from 3D point clouds, creating clean polygons, facility, and space planning. So this end-to-end workflow highlights President ArcGIS complete reality mapping and digital platform. And let's take a look at the Stuttgart, Germany. So this is actually where the reality engine is being developed. So Esri has an R&D center located in this city. So here we're just focusing on this construction site where you can see the foundational reality mapping, the 3D mesh, the 3D scene of ArcGIS Online. And again, we can add 3D information such as BIM, model of this new train station, which is currently constructed, enabling construction monitoring, situation, simulation, and operation in 3D. And lastly, at the regional scale, here's the North Rhine-Westphalia in Germany. So around the world, organizations are laying the foundation for smarter, more resilient communities. And the Ministry of Interior of the North Rhine-Westphalia, Germany, is doing just that through an emergency response digital twins. This is something that could also work in Taiwan. And this digital twin uses this photorealistic 3D mesh to provide a fast, intuitive situational awareness, serving as the foundation of the emergency response twin. So you can view this mesh in a web on an ArcGIS Online. So you can interact with it with the web services that we have, explore the full digital twin of North Rhine-Westphalia, and setting really a strong example of how GIS can serve both the public safety and public good. And they also partnered with a systems integrator called Conterra to develop this cloud monitoring application for disaster management. And using, of course, the highly accurate mesh data that we have and the flooding simulations, they were able to identify which areas would be affected during different flooding scenarios. So this application enables the public safety officials, the urban planners, emergency responders to visualize, assess, and act all from within a single ArcGIS-based platform.
好，那例子这边呢，举了4个例子来从场景、园区、城市到区域去进行一些展示了那英国的 Nottingham 的部分呢，呈现的是一个协助怎么做市政的一些管理的资讯的来源。那以 Esri 的对，然后也可以用 XR 来做展示XR Viewer。那以 Esri 总部来说呢，藉由这个虚拟实境。我们可以掌握到整个园区的现状，然后特别的是在这里收集了从2018年到2021年的移动建物的各个阶段的建筑时候所收集到的资料，所以可以继续一些历史资料查询。 那斯图加特德国的话呢，则是 Reality Engine，就是 Artist Reality 的开发总部在这里，然后 Esri 这边有一个那个研发中心。那在这边我们就可以套叠各式各样的 GIS 的资料呢，来去进行一个数位孪生的资料的呈现，并且可以去做一个新建物的建案的讨论，以及做展示之后可能开发后的情况。那最后的话是一个比较大的区域啦，在德国的北莱茵威斯特法伦州这边呢，我们协助建好这个 Digital Twin 之后呢，可以被用来做比较大区域的一个洪水的应变计划的规划。那时间关系啦，我就很快速的翻完。如果各位对这些例子个别有兴趣的话呢，欢迎也跟我们业务同仁说一下。
With that, so our application, the geospatial intelligence platform, CPC can enable seamless end-to-end workflow from reality mapping through situational awareness to interactive visualization and dashboards that track operational excellence. And from project delivery, platform thinking, from singular product to a living spatial data set, and again, from pixel to insight. So that's what JS as an enterprise system can deliver. That's all I have for you today. Thank you very much.
好，谢谢丽子的说明。那抱歉拖了一点时间了，个人翻译可能还要再加强一下。那我把时间呢交给顾毅。
好，那感谢各位的第一场参与那我们现在先休息一下，休息到那个45分。45分，我们休息快20分钟左右，现在27分左右，那我们休息到45分左右。那下一场的话，就是由 iSight 带来的那个更多日本的案例透过 Flying Sight 的一个部分来强化他们的一个决策救灾上面的使用，当然是有更多的日本案例还有细节来跟各位分享一下好，那我们现在先休息一下，然后休息到45分麻烦各位再度参与一下第二场 iSight 的部分先。
Sorry, I just want to mention that if you have any questions on the technical part of the presentation, I'll be here all afternoon. So just come and approach me, and I'll be happy to discuss any questions that you have.
好，例子说那个如果有任何问题的话，那历史会在这边，然后有任何问题欢迎询问那个历史都很乐意来回答各位关于刚刚所提到一些展示